Hello, today's lesson we're going to go over some logarithmic equations, and this is what the sheet looks like that we're going to go over. You can pause the video and write down some of these if you want to. So 16 problems total. I'm going to rewrite them so that you can see them easier as I go over them. And let's get started. So this one, remember, just like when we did exponential equations, we can use that same one-to-one property to solve logarithmic equations. So the key is, just like with exponentials, we had to have the same base. So if it was 10 raised to something, over on the other side, you had 10 raised to something, you could set those somethings they were raised to equal to each other and solve. But the key was, it had to have the same base. The same is true about logarithms. When we look at these, in order to set what's inside that logarithm right there equal to this one, the base must be the same. And so in these cases, we have 3 as our base. So since they're both 3 on both sides, I can say what's inside of this one must equal what's inside of that one. So 4 minus x is equal to x plus 8. And now look at it. It just becomes a problem like we have in algebra. And we can solve it there. So add x to both sides and you get 2x. Subtract 8 from both sides, you get negative 4 on that side. Divide by 2 and you get negative 2 is equal to x. Now, it is okay for x to be negative. Not a problem with that at all. But remember, what we cannot do is take the logarithm of a negative number, and we cannot take the logarithm of 0. That goes back to the domains of logarithms. So on each of these, whatever we get for our answers, we want to substitute them in on both sides and make sure we're not taking the log of 0 and taking the log of a negative number. So negative 2 gets in right here, and we get the log base 3 of 2. So that's okay. Check it over here. You put negative 2 in, and you're taking the log base 3 of 6. So that will work. There's no issue there, and we do have a solution. It is x equals negative 2. Let's look at the next one here. Log base 4 of x plus 2 equals log base 4 of 55. All good. They do have the same base, so we can set what's inside equal to each other. And so I have x plus 2 is equal to 55. Subtract 2 from both sides, and x equals 53. Once again, substitute it back in and make sure I'm not going to get any error there. I don't, so that one's a good one as well. X equals 53. Our next one, we've got log base 2 of 2x plus 1 equals log base 2 of 15. Once again, the bases are the same. Set what's inside equal to each other. You get 2x plus 1 equals 15. Subtract 1, 2x equals 14. And then divide by 2, and you get x is equal to 7. Just to check, nothing works out to be negative or 0 in there. And you're good with number 3. With x being 7. Let's take a look now at number 4. Now, some of these seem a little repetitive. I want you to get in the habit of seeing same base, set what's inside equal to each other. So the first several questions are a lot alike on all of these, and then we will get to some that aren't so much repetition going on. So hang on in there if you're getting bored, or fast forward a little bit if you can do that. So we have base 5 here, so I'm going to set x plus 1 is equal to 2x plus 7. I'm going to solve for x by subtracting 1 from both sides and then subtracting 2x from both sides. So I get negative x equals positive 6. Divide by negative 1 and I get x equals negative 6. And so now when I look at this, I want to make sure it's okay, once again, for x to be negative. But if I put it back in, I better not take the logarithm of a 0 or a negative number. Putting in negative 6 right here, I get negative 12 plus 7, which is negative 5. So I'm taking the log base 5 of negative 5, which I cannot do. And just to double check, it shouldn't work over here either. I also get negative 5 there. So since this one gives me that issue, I can't have x equal to negative 6, because then it makes me take the log of a negative, which is a domain error. It's kind of like when you take the square root of a negative. Just remember, with logarithms, you can't take the log of 0 either. Square roots, you can take the square root of 0. Either way, because the only solution I found gave me something that's not possible, there is no solution. So I'm going to say no solution on number 4. And so this is something that's tricky for students because so many times when we're doing algebra, the teacher always says, now once you get an answer, substitute it back in, make sure both sides are equal, check your work, right? And we get in the habit of always getting it right, and we never do go back and check our work. And so, yes, in this last problem, number 4 here, I did all my work correct. X does equal -6 when these two are equal. But if I don't go back and plug it in and give it a check, I'm going to say x equals -6 is my solution and then get the question wrong in the test. So you're almost there. Make sure you substitute it back in and make sure you're not taking the log of 0 or the log of a negative number, whatever the base might be. All right, number 5, once again, bases are the same. I'm going to set what's inside equal. So I've got x plus 2 equals 3x minus 5. I'm going to subtract x from both sides, add 5 to both sides, and I end up with 2x is equal to, what do we got here? As 7. Yeah, 2x equals 7. I shouldn't skip steps because then I mess up. Divide both sides by 2, and I get 7 over 2 equals x. Remember to go back and check it out. So if I put 7 halves back in, that's a positive plus a positive, going to give me a positive there. Same thing right here. 7 times 3 is 21, and 21 over 2, I'm just doing the multiplication in my head. You can write it out if you want to. But 21 over 2 is about 10.5, and 10.5 minus 5 is going to give me a positive number. So everything works there. 7 halves is my solution for number 5. So on to number 6. On number 6, we've got, once again, same basis, so I can set what's in the parentheses equal to each other. And I'm going to get x plus 3 is equal to 5x minus 8. I'm going to add 8 to both sides. I get 11 is equal to, subtract x from both sides, 4x. And so 11 over 4 is equal to x. Checking it out, a positive plus a positive will give me a positive, so that's good. And then 11 times 5 is 55, so you get 55 over 4 minus 8. And you could divide that out if you want to. I'm just going to say this is the same thing as 32 over 4, 8 is. And so when I subtract that out, I'm going to get a positive number because 32 is less than 55. So that works. You don't actually have to come up with the actual value here. But if you're checking it, just make sure it's not going to come out to be negative. I'm done. I've got 16 problems to go through, so I'm going to go on to the next one here. Number 7. So number 7, once again, we got the same basis. And we get negative x plus 1 must equal 5 plus, that's a plus symbol, 5 plus x. I'm going to add x to both sides and get 2x on the right side. Subtract 5 from both sides, I get negative 4 over here. And dividing both sides by 2, I get negative 2 is equal to x. Can x be negative? It can. I just can't take the log of a negative number. So when I put this in, be careful here. This is negative x, so I'm going to put negative 2 in, and it's like I'm saying negative 2 plus 1. And a negative 2 is a positive 2, right? So I'm really taking the log base 5 of 3 right there, which is okay. And then when I put it in over here, I'm going to take 5 minus 2. I get 3 there as well. That's okay. So this solution right here works. So x is negative 2 for number 7. Let's look at number 8 now. Number 8. Doesn't that look just beautiful? So now we've got a case here where it's just not a log equal to a log. We've got a log plus a log equals a log plus a log here. So what I want to do is start to condense some logarithms. So we need to go back and look at the properties of logarithms. Let me grab that worksheet we produced in the last video. So right here it is. It's not really, it may not have been the last video I made, but it's on one of the ones talking about the properties of logarithms. Remember, if we have the log base 10 of a plus log base 10 of b, it equals the log base 10 of a times b. And this really works for any base. It could be log base 3, so long as it's base 3, base 3, base 3. So it has to be that same base all the way across the board there. In this case, we got base 2. So log base 2 of x plus 2 plus log base 2 of x plus 1. We can say that's the same thing as log base 2 of x plus 2 times x plus 1. And that's going to equal the log base 2. We can combine the same thing here. They're both the same bases, and we're adding, so it's going to be x times x plus 4. And so now we've got 1 log equal to 1 log. That's what we want. 1 log equal to 1 log. And they're the same base, so we can set what's inside equal to each other. So I get x plus 2 times x plus 1 is equal to x times x plus 4. And I need to do a little bit of algebra here. So I'm going to multiply this thing out. X times x is x squared. X times 1 is x. 2 times x is 2x's. 2 times 1 is 2. So I'm just foiling that thing out. And that's going to equal, distribute the x over here, x squared plus 4x. And so now I'm going to move everything to one side and see if I can solve for x. So if I subtract x squared from both sides, these x squares just go away because there's just one on each. If I combine this x and 2x, I actually get 3x's right here. And I'm going to subtract 3x from both sides. So subtracting 3x from this side gives me x by itself. And subtracting 3x from this side knocks that x and the 2x out. And so I end up with just x equals 2. Now, it's important, I've got a lot of logarithms in here. It's important that I go back and make sure at no point I'm taking the log of 0 or a negative number in my work here. So if I put 2 in, I get 4 right there. That's okay. That's a positive number. Put 2 in right here, I get 3. That looks good. Put 2 in right here, I get a 2. And then put 2 in right here, I get a 6. So at any point, if I'm taking the log of 0 or a negative number throughout my work with x equals 2, I've got an issue that cannot be a solution. But in this case, I have no issues with x equaling 2. I will allow it, right? Let's look at number 9. So they picked up the pace in the last problem, making you use properties of logarithms. Now they're not going to slow down on you. Same thing again. We got an addition sign in between two logs at the same base. Let those things be combined. So we've got log base 2 of x times x plus 1. And that's going to equal log base 2 of negative 4x minus 6. So I've got 1 log over here, 1 log over there, same base, base 2. And so I can set what's inside equal to each other. So x times x plus 1 is the same thing as x squared plus x. And that equals negative 4x minus 6. I just distributed the x there if you're wondering where I got that. Distribute the x. And now I'm going to say move everything over to one side and see if we can solve for this thing. So add 4x to both sides, you get x squared plus 5x. Add 6 to both sides, you're going to get plus 6 right there. And since I added 4x and added 6 to the right side, I get 0 on the right side. And look, we got a quadratic here. I'm going to try to attempt to solve this just by factoring, which I think it will factor pretty nicely. So I want factors of 6 that add up to the middle term 5. I usually write the other way around. Factors of 6 that add up to 5. I've got 1 and 6. No, that's not going to work because 1 times 6 does not equal 5. Or 1 plus 6 doesn't equal 5. I've got 2 and 3. That looks more like it. 2 plus 3 is 5, and 2 times 3 is 6. Because the leading coefficient is 1, I can take the shortcut on this and just say x plus 2 times x plus 3 equals 0. So that's what it factors to. So x equals negative 2 and x equals negative 3. Last thing I need to do before I call this thing done is to go back and check and make sure I don't get any negative numbers up here or 0. So if I put negative 2 in up here, I get the log base 2 of negative 2. That already throws up a red flag. Negative 2 cannot be a solution. If I put in negative 3 into this thing, negative 3 right here also gives me log base 2 of a negative number. I don't even have to check the rest. I get an issue right there with that first one. That throws out this one. And so that tells me there is, since neither one worked, there's no solution. Now, had negative 2 not worked, but say this were a positive 3 and it works out, I don't even think positive 3 will work out. But if it did work, we can have a case where we factor it to 2 solutions right here, and one doesn't work and one does. That sometimes happens. But in this case, neither one worked. So no solution for number 9. All right, a few more left. Let's look at number 10. So number 10, once again, we got to combine some logs here to get this thing going. So I'm going to say everything's in base 2. It's always good to check, make sure we got same base, no tricks or anything like that. And so I'm going to say x minus 2 times x minus 5. And this is log base 2 of that, is equal to log base 2 of x minus 1 times x plus 6. So to save you some time, I'm going to pause the video and just FOIL this out. So bam, there it is. That's it foiled out. And all I'm doing is just multiplying these out. If you don't see what I did there, ask me a question. I'll be happy to answer it to you. But that's foiled out, combined like terms. And now I just need to get everything over to one side so we can solve here. So if I subtract x squared from both sides, these are going to cancel. If I add 7x to this side, so add 7x to both sides, I'm going to end up with 12x's on the right side. And I'm going to go ahead and add 6 to both sides. And so let's see what happens here. So 7x and 5x give me 12x. These cancel. This gives me 16. Those cancel. I get 12x equals 16. Divide both sides by 12. You get 16 over 12 equals x. And this will reduce. 4 goes into both. So you end up with 4 over 3. Now that looks like my answer. Let's make sure it doesn't give me a negative number. 4 over 3 is the same thing as, what, 1 and a third. So 1 and a third minus 2 is going to give me a negative number. So that's going to give me an issue with this. And I don't even have to check the rest. I got one that was an issue, so it's no solution. Watch out for those. Make sure you're going back in and checking those. Number 11, once again, let's combine these logs. We get log base 2 of x times x minus 6 is equal to log base 2 of 2x minus 7. We got 1 log equal to 1 log. The bases are the same. Set what's inside those parentheses equal to each other. And I'm going to go ahead and make it one step where I distribute this x while I do it. So I'm going to go ahead and multiply that out. I get x squared minus 6x is equal to 2x minus 7. Move everything over to one side so I can solve it. So if I subtract 2x from both sides, I get x squared minus 8x minus, or I'm going to add 7 to both sides, plus 7 equals 0. Let's see if this will factor. I want factors of 7 that add up to the middle term, negative 8. I've got 1 and 7. If I make them both negative, that gives me a positive 7 when I multiply them. And when I add them, I get a negative 8. Because the leading coefficient is 1, I can take the shortcut and say this is x minus 1 times x minus 7 equals 0. So x equals 1 and x equals positive 7. That looks promising. Let's see what it does when we put it into log base 2 of x. Both 1 and 7 work there. When I put 1 into this one, though, log base 2 of x minus 6, 1 minus 6 is a negative 5. Can't take the log of 0, can't take the log of a negative number. That means we got to throw that x equals 1 out. It worked on that one, but not on that one. Throw it completely out. Doesn't do us any good. 7, though, is still alive. 7 minus 6 is 1. That looks good to me. And then if we say 2 times 7 right here, we get 14. And 14 minus 7 is 7, a positive number. That works. So in this case, we got it down to 2 solutions. One didn't work, one does. X equals 7 is our solution there. All right, so that's number 11. Let's look at number 12. So here's 12. Doesn't that look fun? I had to write it below so I could fit it on the page. Once again, we can just multiply these out to combine them. So I'm going to get the log base 2 of x minus 2 times x minus 8 equals log base 2 of x plus 1 times x minus 9. And so I'm going to once again FOIL those out. I'll pause it to save you that, but if you have a question on how to FOIL it out, either watch one of my videos on foiling or just send me a message. Let me know. All right, so here we have these two binomials multiplied out and then the combine of like terms there. And I'm going to go ahead and subtract x squared from both sides. That knocks those out. And then I'm going to add 10x to both sides. So I'm moving that 10x over, and I'm going to add 9 to both sides to move the 9 this way. And so that's going to cancel out the 10x there. It's going to cancel out that negative 9 right there. Negative 8x plus 10x gives me 2x's. And 16 plus 9 is 25, which means x equals 25 over 2. I'm almost ready to call that an answer. That's like 12 and a half. Let's put it in and make sure it works everywhere up here. 12 and a half minus 2, that looks good. 12 and a half minus 8, yep. 12 and a half plus 1, that works. 12 and a half minus 9, that works. So I don't even have to really calculate it. Just make sure that, you know, it's not even an estimate. 25 divided by 2 is 12.5. But I'm just looking through and making sure everything I'm subtracting is not equal to or greater than 12 and a half. So I don't get any negatives or zeros inside my logarithms there. So that one right there works for us. Now, 13. Let's take a look at number 13 here. Notice that, yeah, we can combine these again like we've been doing. Let's go ahead and do that. We've got a plus symbol, same basis. So we got log base 3 of x plus 2 times x minus 3. So we got that going on. We're going to have to multiply this out. Be careful with what's going on right here. See that 2 out front? Remember, if we go back to our properties of logarithms, if a number is out front, we can move it and put it as an exponent right here, or vice versa. If we got an exponent there, we can stick it out front. Here, we're going to move it now so the logarithm is by itself. So I'm going to take that 2 and I'm going to move it to right here and say x plus 1 squared. So I got the log base 3 of x plus 1 quantity squared. So what I'm going to do now, these two are equal. I'm going to go ahead and multiply that out, and I can use my shortcut for that. I can say, okay, I know that x plus 1, that binomial squared, you square the first term, square the last term, multiply the 2 and double it, and this is what you get. I'm going to set, since these bases are the same, I'm going to set what's inside here equal to what's inside right here. And just like the one up above, I'm going to pause the video and just FOIL that out to save you the time there. All right, and combining those like terms, this is FOILing it out, and that's what I got in pink when I FOILed it out. And then combining my like terms, I get this right here. And so now I'm in that situation again where I want to move and, well, solve for x. So I start by subtracting x squared from both sides, and look at that, the x squares disappear. That always makes life easy. Add x to both sides, and I get 3x down here. And so that's gone now. I'm just kind of marking things off so I don't forget something. And I'm going to go ahead and move that 1 over. So if I subtract 1 from both sides, I get negative 7 on the right. And that, everything is taken care of. 3x equals negative 7. Divide both sides by 3, and I get negative 7/3 is equal to 8 there. So remember, it's okay for x to be negative. What I don't want is to be taking the negative of a logarithm. So negative 7 over 3 is the same thing as negative 2 1/3, because 3 goes into 7 twice, and then you got 1 left over. So it's negative 2 1/3. If I put that into this right here, negative 2 1/3 plus 1 is going to be negative 1 1/3. So that's giving me an issue. And so right now I can go ahead and say, nope, stop the party. That's not going to work. No solution right there. So you do all that work. Some students get upset. They say, you know, I do all this work, and then at the end there's no solution. It's okay. No solution is your answer, and you're getting the answer right. So who cares if it's x equals 4 and that's the answer? Or who cares if x doesn't equal anything, you get no solution. You do work either way, and you get credit either way for getting the correct answer. So don't feel too discouraged if you're getting a bunch of no solutions. Feel good that you know that you can't take the log of 0 or a negative number. Let's look at number 14. So there we go. We got log base 2 of x plus 5 is equal to negative 1. So what are we going to do right here? In this case, I think what we want to do is convert this. I think it's easiest to convert it to exponential form. So there's a couple ways we can look at it. And you know what? I'm going to show you both ways. Let me get a piece of paper, scrap piece of paper. And I will show you 2 ways to do it. So let me just copy this over before we get started here. If we had log base 2 of x plus 5 equals negative 1. So the first way I can show you is this. You got log base 2 of x plus 5 equals negative 1. Now we talked about before putting these things in exponential form, or converting from exponential form to logarithmic form, or the other way around. That's what I'm going to do here. I know that 2, that's my base in the logarithm. I'm going to say 2 is my base in my exponential form. And remember, a logarithm is an exponent. So this is the exponent that makes this logarithm work here. It's going to be the exponent of my exponential form. And it must be equal to the input of my logarithm. So that equals x plus 5. All right, so all I did there was convert it back from logarithmic form to exponential form. If you don't have a clue of what I'm talking about there, go back and watch my video on that. So 2 to the negative first is the same thing as 1 over 2 to the positive first, right? I'm just taking that, writing as a fraction, and dropping it down below. So 1/2 equals x plus 5. And to solve for this, I'm going to subtract 5 from both sides, and that gives me x equals negative 4.5. Right? 1/2 minus 5 is negative 4.5. Just to double check, you still need to go back and put it in the logarithm and make sure you're not taking the log of 0 or a negative. And negative 4.5 plus 5 is a positive 1/2. It can be a fraction, just can't be 0 or negative. So that works. So you say, you know what, maybe you like that way, maybe you didn't. The camera here says that's it, lights out. That's a good one right there. No, the battery died. Let me pause it. I'll change the battery. All right, got that battery switched out. I'm back now. If you've been following these videos, my battery dies occasionally, and so I ordered some new batteries on Amazon. I've been really wearing these things out. On this, though, here's another way you can do it. So the last one we said, all right, switch it to exponential form and solve. This is almost the same, but you're thinking about inverses to a function. So the inverse of log base 2 is 2 raised to something. So we're going to say, take 2 and raise it to all this mess right here. So we call it exponentiating both sides of the equation here. So I'm also going to say 2 raised to that power. So whatever this base is, that's what I'm going to exponentiate both sides to. Since these are inverses to one another, log base 2 and 2 to the x, they cancel one another out. It's like saying multiply by 5 and divide it by 5. They would cancel out. These cancel each other out, and I'm left with just x plus 5. On the right side, though, I have 2, because I did it to the left side, I said 2 raised to everything there. I'm going to say 2 raised to everything right here. In this case, it's 2 to the negative 1. And notice what we got. We got the same thing going on right here, right? So when you solve this, you can say, hey, that 2 to the negative 1 is the same thing as 1/2. Subtract 5 from both sides, and x equals negative 4.5, which is the exact same thing we got. And of course, you would still have to check it, but we already checked it, so we're not going to do that again. You do which way you like best. Some students like doing it this way, some like doing it that way. And I think some problems make it easier if you do it one way over the other. So as we go through problems together, I'll do another video on just a bunch of hard problems like this stuff, and we'll learn which way to look at it in the future. All right, that being said, let's look at number 15. 2 more problems to go here. Number 15, once again, we got a logarithm equal to a number. Let's go ahead, and I'm going to use the switch to the exponential part there, because I think the exponential form is a way a lot of my students choose to use. So I'm assuming that most of my viewers right now, or if you're one of my students, which most of you are my students, you're going to choose that way also. But if you don't like it, do the other way. Here's my base 3. I'm going to raise it to the 3rd power, and that must equal x minus 2. 3 to the 3rd is 27. So 27 equals x minus 2. Add 2 to both sides, and 29 is equal to x. Double check it. 29 minus 2 is 7. And that is a positive number, so that will be okay there. Number 16. Number 16, once again, I've got base 2. I'm going to make it in exponential form, so 2 raised to the 0. That must equal what's inside here, 2x plus, not 2x, 2 plus 3x. And then I need to solve for x here. Now, 2 to the 0 is the same thing as 1. So we get 1 equals 2 plus 3x. Subtract 2 from both sides, and you're getting negative 1 equals 3x, or x is equal to negative 1/3. Remember, okay for x to be negative, but you can't take the log of 0 or a negative number. When I put this in, negative 1/3 times 3, negative 1/3 times 3 equals negative 1. And 2 plus a negative 1 is positive 1, which is perfectly fine to have. So x equals negative 1/3 is my winner there. All right? I hope going through these you feel a lot more comfortable solving logarithmic equations now. Either way, if you're in my class, I'm going to make you do more, and I'm going to make you do more challenging problems, but this is just getting us started here. So hopefully you went through this, and by the end of doing all 16, you said, you know what, I got this. If you didn't feel like that, talk to me, and we can go through some more, or if you have specific questions, let me know. All right? Thanks for working hard, and thanks for watching.